All right, guys, so let's take a look at number 15. So we get sine x plus cotangent x times cosine x. So what I'm going to do here is I'm going to go ahead and replace cotangent x with cosine over sine. I'm just going to change everything to my sines and cosines. Remember, that was one of our strategies. So when I do that, I get sine x plus cosine x over sine x times cosine x. So now what I can go ahead and do is just multiply this over here, if I want to put that over 1. So then this would be sine x plus cosine squared x over sine x. So now we're looking and we're saying, well, what else can we do here? Do I want to use a Pythagorean identity? That's going to make it more difficult if I do that, because then it's going to give me, a subtraction up top here. But then I see this here with the denominator of sine x. Well, if I want to add fractions, I just get a common denominator. So this would just have a common denominator of sine x. So let's go ahead and do that. So if I put a sine x here with my common denominator, obviously this side, nothing is going to change because it already has the common denominator. Over here, I have a sine x up top. If I want to put this with the sine x in the bottom, that means I have to multiply the top and the bottom by sine x. So that is how I am correcting for my numerator. So then this would give me sine squared x plus cosine squared x over sine x. I can do that because now that I have the same denominator, common denominator, I can add these two together over the common denominator. Well, look in here, sine squared x plus cosine squared x, hopefully you look at your Pythagorean identities, that's equal to 1. So give me 1 over sine x, and then of course 1 over sine x is equal to cosecant. And that problem is simplified. So let's go ahead and look at number 16. So for 16, we have cosine x plus sine x times tan x. So this is somewhat similar to number 15. Again, we're going to wind up using a common denominator. And for the problems that we're going to do here, that's pretty much the theme that we're going to work with. So I'm going to go ahead and replace tangent. So tangent is equal to sine over cosine. So times sine x over cosine x. And then of course I'm going to go ahead and multiply like I did over here. So that would give me cosine x plus sine squared x over cosine x. And now here my denominator is cosine x, over here with sine x. So this is going to be my common denominator. So I'm going to correct this numerator. If I put it over 1, just so you can see it's the fraction, if I want to have it as a common denominator cosine x, I have to multiply the top and the bottom by cosine x so that I get that common denominator. And then this is sine squared x over cosine x. So now I can multiply this together and put it over the common denominator just like I did over here. So that would be cosine squared x plus sine squared x over cosine x. And then you can see here, it's the same thing. Sine squared x plus cosine squared x is the same thing if you reverse it. So then this would be 1 over cosine x. And then of course the reciprocal of cosine is secant. So this would be secant x would be our simplified answer. All right, we'll go ahead and take a look at number 17. All right, so number 17, see it looks a little bit different. We already have the fraction set up. Here we have a sine x in the denominator, and here we have a cosine x. Well, we could just find a common denominator and subtract those so we get it to be as a one fraction. So if I got a sine x here and a cosine x here, the only thing I'm going to be able to do is to multiply those two together to get my common denominator, which is going to be sine x times cosine x So I'm going to go ahead and write that out with my common denominator. Now I already have a secant x up here, and I have a sine x up here. So now if I want to get this to be my common denominator, I got to multiply top and bottom by cosine x, so I keep the fraction equal. So I have to multiply top and bottom by cosine x. And then over here, if I want this to be this, sine x times cosine x, I have to multiply by sine x, top and bottom. So I'm going to go ahead and do that. Sine x and sine x. So now I can go ahead and swap out, since all these are sines and cosines except for the secant here, I can go ahead and replace that with 1 over cosine. So that would be 1 over cosine x times cosine x over my common denominator minus sine x times sine x over common denominator. I could have multiplied that out if I wanted to. I'm just going to do it all here now. So from here, if I multiply this together, that is just going to give me 1, because cosine over cosine is 1, minus sine x times sine x is sine squared x, and I'm going to put this whole thing over my common denominator, because I have the common denominator, so I can do this minus this over the common denominator, multiply 1 over cosine times cosine x, that gives us a cosine over cosine, which is 1, sine x times sine x is sine squared x. Well, what can we do here? We're looking at 1 minus sine squared x, go to our Pythagorean identities, that is cosine squared x. So then I have cosine squared x over sine x times cosine x. And then we look to see, is there anything else that we can do? Well, I have 2 cosines up top, and I got 1 at the bottom, so if I cross 1 out here, cross 1 out here, that gives me cosine x over sine x. And then finally, cosine over sine, that is equal to cotangent x, quotient identity. So that one simplifies all the way to cotangent x. All right, let's take a look at number 18. Slide this down a little bit so we can see that. So 18, we have sine x over 1 plus cosine x plus cosine x over sine x. So again, I got these fractions. This time I got a 1 plus cosine on this side, and then I have a sine x over here. Well, the only thing I'm going to be able to do to get a common denominator is to multiply these two together. So this would be sine x times 1 plus cosine x plus sine x times 1 plus cosine x. So I already have a sine x up here. I already have a cosine x up here. Well, what do I have to do to correct? This I have to multiply by sine x. So I'm going to multiply the top and bottom by sine x. Highlight that so you can see. This I need to multiply by 1 plus cosine, so that means I have to do that as well up in the top. So now I can go ahead and multiply this together, and I can distribute this right here. So this will give me sine squared x over my common denominator plus distribute cosine x times 1, cosine x times cosine x. So that would be cosine squared x over, and then I got my common denominator. So now what I can do is put this whole thing over my common denominator. So that gives me sine squared x plus cosine x plus cosine squared x over my common denominator. And now what can I do? You see here you have a sine squared x and a cosine squared x. Well, sine squared x plus cosine squared x, Pythagorean identity, that is 1. So now it would just leave me with 1 plus cosine x over sine x times 1 plus cosine x. Well, is there anything else we can do? Well, this is multiplying times the 1 plus cosine x. And I got a 1 plus cosine x up here. So I can go ahead and reduce that. Think about factors. If you had like an x plus 2 in the top and an x plus 2 in the bottom, you can go ahead and reduce those. Same thing here. So that would just leave me with 1 over sine x. And then once 1 over sine x, we can finally simplify this to cosecant x. And that one is finished. So we'll go ahead and take a look at the last one in this group, number 19. All right, guys, so looking at number 19, this one is a little more difficult. So when you're looking at this, you're saying, well, what is it that I can do? I mean, I already got a sine, I got a cosine, there's not much else I can do. Well, if you recall when working with complex numbers, when we wanted to simplify the denominator because it had an I, you would multiply by the complex conjugate. Well, that's what we're going to do here. We're going to multiply by the conjugate. So let me show you what that looks like. So if I have sine x over 1 minus cosine x, the conjugate of 1 minus cosine x is 1 plus cosine x. So I'm going to multiply that by 1 plus cosine x. Well, then I have to multiply the top by 1 plus cosine x. So you might be saying, well, how does that help me? Well, if you multiply by the conjugate here, that's going to create the difference of squares, which then we can use a Pythagorean identity to help simplify this. So if I go ahead and multiply the bottom out, up top I have sine x times 1 plus cosine x over, and I multiply the denominator, that's going to give me 1 minus cosine squared x. Now you might be saying, well, why don't you distribute the top here? Because when I see this and I recognize when I multiply and get the difference of squares, I know that 1 minus cosine squared x is equal to sine squared x. Then I'll be able to reduce one of those, where if I distributed that, you would have to factor it back out and do an extra step. So I'm going to go ahead and replace 1 minus cosine squared x with my identity sine squared x. So I have sine x times 1 plus cosine x over sine squared x. And then, like I said, I can go ahead and reduce the one up top here with 1 in the bottom. So that leaves me with 1 plus cosine x over sine x. And now you're saying, well, all you did was all that simplifying. Now I just have the binomial in the top as opposed to in the bottom. How does that even help me? Well, I can split this off now. So this is equal to 1 over sine x plus cosine x over sine x. And then by doing that, 1 over sine x is equal to cosecant x, and then cosine x over sine x is equal to cotangent x. And that is simplified. So I know this one was a little bit more difficult. You can tell as we're progressing that will happen. So this basically ends in this part of the video simplifying. So in the next part, we're going to go ahead and start verifying trig identities.